Okay, thank you, Cloud Person. Okay, good afternoon. Today, we will continue on with our discussion, but we'll have a little bit more material on things concerning the design thinking book. Because one of the things that you'll be doing is identifying your quote unquote customer or cohort of customer and trying to find an IoT solution to a problem concerning something to do with campus. And I'll talk a little bit more about that. We will also today have you give your 5-minute group presentations, and we'll just cycle through the groups. So please pick someone. The URL for my Zoom room is on the Slack channel, and it works easiest to have people share screen to show the slides, so we avoid all those issues that usually happen when you disconnect and reconnect laptops physically to the cable. All right, but before we begin, some administrative bits. The reading has changed by a week from today, which is the 8th of February, and it's kind of hard to believe it's already February, right? Today's the 1st. We were just thinking about the holidays not that long ago. In the design thinking book, roughly section 1.1, pages 12 through 35. As I always say, please make sure you're doing a little bit each day. Don't wait until something's due to start looking at things. Project number 3 is out on the Blackboard. It's due a week from today, the 8th, at the usual 11:59 seconds. I call it the AHA alarm. You'll find out when you read it why I do that. For that, you'll also be doing a 4-point exercise to get a lot more practice with this. And you'll be handing in the usual design document, code, notebook, reflection, etc. And so please make sure you're taking a look at that material, because we will have a comprehensive exercise with the sense, think, act cycle in the lab portion on Friday. Okay. Any questions? And I know project 2 is due this evening. Any questions about that? No? All right. The key masters, Dr. Basie has submitted those names, 2 names for each group. To, I think it's campus police or IT, one of the 2. And shortly, you should have badge or card key access to the room. I'm going to leave all of the IoT kits in the front corner of the room so that you can, through your key masters, through your group, access the room to work on your projects outside of the class. Please make sure you clean up all of your components and things when you're done. And please, if you could return your Cerulite container, the plastic bin, to the location up at the front, and I'll just cross my fingers and cross my toes. Hopefully nothing happens to it, because if something happens to the kits, basically we're doomed, right? We don't have replacements for all of the stuff. All right, any questions? No questions? All right, so my 9-year-old dared me to tell dad jokes in class. So one of the things she knows is you don't dare me. So I'm gonna try a couple out on you. What do you call a company that makes okay products? That makes okay products? No? See, I didn't have these in the slide, so you can't look. A satisfactory? No? All right. Okay. What did the beaver say when he slipped in the water? Damn it. Okay. This is one of her favorites. Why was 6 afraid of 7? Because 7, 8, 9, that's pretty, see someone get eaten, it's pretty bad. All right. Anyways, so why don't we continue? They don't have to be funny. All right. So when we last left off, we talked about coding a finite state machine. And we followed a prescription for that to walk you methodically through the process. And I stressed then, I'll stress now, follow the process, resist the temptation to want to jump into the implementation. Follow the process so that you learn it while things are relatively simple, because as we layer on more complexity, it's not going to be so straightforward to kind of just jump right in and implement it. And so we went through that process. We talked about define your states, define your algorithm, draw your graphical finite state machine. Then you define your states, make your switch sandwich or loop sandwich, as we call it. Then wiring your transitions, focusing on the positive logic. and then put in the conditionals, and then add in the API calls lastly for the implementation of the behaviors. And what we'll see, no, I won't pre-announce that. We'll see a variation of that on Friday. We also talked about the 4 points, which is a framework based on the Heilmeyer catechisms for guiding an open-ended research and or engineering project. And those 4 points are: what is the context? What's current state of the art? What will you do? And what is the impact? And we talked about the questions and considerations that each of those 4 points answers. We also have a link to 2 undergraduate examples with George and Comlin for a capstone project, which is a 1 semester thing at my previous institution, where they run through all of those points. Now, we're kind of doing this at this juncture, the 4 points, with projects that are known, but this is really tuned to open-ended questions. We have to figure out what the question is and figure out the architecture before and while you're executing. But in this case, the answer is already known for things like the 4 LED bounce chaser, and you're just imagining if you were doing this without executing the project ahead of time. So there's a little bit of a mismatch, and the reason is to give you practice with this before we jump into it for real. Okay? All right, any questions? No questions? All right. So we also talked about the 4 LED bounce chaser, and we gave the canonical circuit for one of the LEDs, and we said we need a 220 ohm resistor effectively to limit the current that is drawn across the LED. And with that, for dealing with the components themselves, it's important to remember which of the pins is the anode, the positive side of the LED. And for the bounce chaser, you're replicating this circuit 4 times, and you're programming accordingly, and you choose the digital I/O pin that of choice that you desire. Any questions? No? All right. So let's pivot to the 5-minute group presentations. And so you'll each have 5 minutes. And thank you for joining the Zoom room. We will have the first person up who wants to go. Just somebody share your slides, please. I should have the presentation settings correct. Let me see. Let me see. Are you able to share your screen? No? Oops. Uh-oh. No? Somebody? How about this group? Let's have somebody go. No? You ready? All right. So, all right, let's have this group. All right, so connecting to audio. We have 4 groups. Jeffrey, are you able to share the screen? You can't. All right, let me, sharing options. All participants can share. Okay, how about now? Oh, let me stop my share. That's why. All right. Okay, here we go. Okay, there we go. All right, so please let's give them our professional treatment and let's limit the side conversations and be good colleagues to whomever is presenting. All right, so why don't you do it stand in place and make sure, please, to enunciate. If you want to turn and face your audience, you're welcome to do that, or just, use your best voice. Thank you. Let's thank them. All right. Light bulb crap. Okay. All right. So let's have the next group, please. Yes. Okay. And this gets easier over time. And please make sure to enunciate so we can all hear you. I find with a mask, sometimes you have to semi-shout, and so people aren't used to that. Okay. You can get ahead. You're talking to them, not me. Thank you, Ms. Thinker. All right, let's have the next group, please. Next group, there we go. And remember, you're speaking to your colleagues, not to me, and try to enunciate through the masks. And you can begin. let's thank our speaker. All right, next group. Remember, you're talking to your colleagues, not to me. Great, thank you. Let's thank our speakers. All good stuff. So let me continue on, and anything that we have the balance of, we'll just finish on Friday. Let me share my slides again. Share. And so by the end of the semester, this should all just feel like a reflex, right? Second nature. Great. Thank you, everyone. Slideshow. Let's see. Let me make this more. Check. Okay. Mic is still hot. All right. Why don't we continue forward? Why is this doing that? Why is the ribbon down below? Let me do this again. Okay, slideshow. I shouldn't have a ribbon. There we go. Somebody's still connected to the Zoom session. Please bear with me. Slideshow. There we go. And we're back. All right. Thank you, everyone. So let's take a look at something called persona development. And so when we talked about the 4 points, that first point, what's the context? Among several things we discussed, we said you're trying to identify the target audience for whom you're proposing some solution. Now, of course, you don't describe each person. You're going to describe the attributes that defines this particular cohort. The business folks would call it market segmentation. You have to identify the market or the cohort of people who will be the main consumers of what it is you're enterprising to do. You're going to address some aspect of their day-to-day life. And so great design requires you to have a deep understanding of the user who's going to use your products or your solution or your system. Because the better your understanding of their needs, their lifestyles, their wants, their hopes, their dreams, the more engaging your design will be. And so the best solution isn't always the most elegant. It isn't always the prettiest. It isn't always the most technical. It's that which most sufficiently satisfies the needs of your users. And so how do you get to know who your users are? In the design thinking book, they talk about something called a persona. And a persona is kind of like a cartoon, a caricature. It captures the essence of who the person is. Now, of course, and that's The Rock or Dwayne Johnson, if you don't know who that is. When you capture the essence, you're representing that person's lifestyle whose needs you're trying to fill, you're trying to address. And so you need to understand both their personal life, the day-to-day goings on, as well as their professional life. And this creates something called empathy. Now, a long time ago, I learned the distinction between sympathy and empathy. They're not the same. Sympathy is when you feel bad for someone, you feel sorry for someone. Empathy talks about, I've walked in your shoes. I know your experience. You cannot empathize unless you've been through something that's the same or similar. And so the idea of the persona is trying to capture enough that you can articulate this empathy associated with the target cohort you're trying to identify for your product or solution. Any questions? No? All right. And so how do you do this? You're going to have to go out and you're going to have to gather some data. You're going to conduct user research. Now, you could get a graduate degree just in design or human-centered design, user, psychometrics, all that stuff. You could spend a whole master's degree and in some cases a PhD on it. So we're not going to give it the full treatment that it deserves, but you're certainly going to have to go out and find these people and collect data. Now, when you build a persona, again, it's a sketch, it's a caricature. And this isn't necessarily, this persona, a real person, but, and this is the key part, you have to be able to go out and find an example in your population. So if you were doing user research about something at Clark, the student experience, and you said, what type of students come to Clark? Commuter students. Well, go out and find someone who's a commuter student. Those who live off campus, go find someone who lives off campus. Those who live in the dormitories, go find someone who's in the dormitory. Maybe it's a traditional student who's gone to Clark right after high school. Maybe it's a non-traditional student who's had some life or career or family experience prior to coming to Clark, not directly from high school. And so the key, when you draw these personas, it's not just one caricature, it's multiple caricatures that you must be able to instantiate within the cohort of the population to whom you're pitching your solution. Okay? Any questions about this? No? All right. So the topic we're going to address for this course, and it's an ambitious one, I'm an INTJ, is student life. And college is a peculiar thing. Student life, you've heard the term. Within student life, you heard something like student success. But student life is immensely important because, as you'll probably agree, college is a period of a lot of change. Now, in college, several things will happen to you. The academic things, you'll learn lots of technical stuff within the discipline in which you're majoring. You'll learn lots and lots and lots of information. Some of it will challenge what you believed before. Some of it will reinforce what you believed before. Some of it will be things completely new that you've never encountered before or never heard before. Some of it will bring those aha moments. That's why this thing happened. So there's absolutely the academic side in college, and we all know that, but there's this professional part. And when the administration created this new designation, C2C, curriculum to career, it's making deliberate these important skills that are important for a career, these professional skills that aren't necessarily taught as part of a class. And so what sort of professional things will you learn? Time management, whether indirectly through the bumps and bruises, making your mistakes, or through explicit planning and instruction, you have to learn how to commit your resources and your attention span to blocks of time. You'll also find out networking and whether, whether, your mind, you kind of filter it out and then it's gone. It's like, wow, it's different here. But, there, no, all right. But when I raised my left arm, it stopped. But anyways, I digress. Networking. Whether you like it or not, for some, I would say many types of opportunities or pieces of information or tools, it's who you know. And as the old saying goes, or at least the one I learned, don't hate the player, learn the game, right? Networking is very, very important because there are a lot of people who have already done the things that you're enterprising to do in life. Ask them. And even the busiest people I've found are more than happy to share with you all of those bumps and bruises that they encountered to save you those steps. So networking is very, very important. Career pathways. Important not just to understand your vocation, understanding networking and security and stochastic computing, I threw that in, and stuff like that, but also be a student of your discipline. Where is computer science going? Because I always advise my students, You should focus on something that is growing, right? The reason for that is that you can grow in your career while this discipline is growing. Shortly after I graduated undergrad, this thing called Java came out. So I said, I want to learn that because nobody had 10 years of Java experience that wasn't Java, right? So understanding not just the technical bits, the academic side, also understanding and being a student of your discipline, know where the market is going, okay? An example of that, I had a student, Rick, from my previous institution. Rick, very hardworking, modest young man from a rural part of Delaware. He worked in the cabinet department at the local Lowe's department store, okay, the hardware store. And so I asked Rick, what are you doing this summer? He said, well, I was just going to work at Lowe's. Nothing wrong with that. I asked him, have you ever thought about an internship at corporate Lowe's in North Carolina? He had never thought of that. And so, long story short, he took the internship, worked the summer, went to North Carolina, knocked it out of the park. And one of the key differentiators is while he was working in DevOps and IT over that summer, he actually understood what happens in the retail branches, not just in the corporate office. And so he spent a couple years there, and now he's at an energy company doing DevOps and device work and stuff like that. So understand how your entrance ramps are and your exit ramps, what's there to chart out your career. Don't make it a mistake. And there are lots and lots of resources out there. Okay, then this last one is something that you'll go through as part of student life at a university, the personal side. If you go your 4 years, and if it's 5 years, there's no shame in that or more at Clark or any university. If you leave the same as you arrived, you're doing something wrong. You're gonna change personally, right? You have to change personally. Now, this could mean things like growing, changing or expanding the things you know, learning how you learn. How do you best absorb information? Things like your personality and how you navigate best in the world. You'll develop friendships and relationships. Some of my lifelong friends I met in college and some before that. Self-actualization, who you choose to be as you go forward, as well as new experiences and new adventures. All of that in one small environment, packed into 100 some odd acres, mixed up over 4 years. Now, student life is so important. Universities pour millions and millions of dollars and resources and facilities into this thing we call a college experience, this student life. You have things like dining, whether you like it or not, and I don't know the Clark food, some like it, some don't like it. Student organizations, expanding your horizons. The arts, all sorts of opportunities are there to try to foster all of these areas of growth beyond just the classroom. It's really, really important. Now, how do you find out the information, the user research, that'll allow you to develop these personas, these caricatures? Because you're not going to create them without going out and talking to people. And so you'll be doing a community survey. Now, there are two major modalities. You could do it in person, or you could do it online. And each has its drawbacks and its benefits. And these aren't the only drawbacks and or benefits. When you're doing things in person, your contact could be a cold contact. You just walk up to someone you don't know, or a warm contact, somebody who has some connection to you, i.e. in your network already. Now, of course, when you make a cold contact, you can have something called location bias. And when I say bias, I mean the statistical word, meaning it's not random, meaning all of the objects of consideration are not equally likely to be selected. Because if you're on this part of the campus with biophysics and computer science and biology, if you're standing in this area, you're more likely to see folks from those majors versus on the other side of campus. So that's something to consider. When you have a warm contact, well, you have selection bias. because maybe you know some cohorts of the campus community, but you don't know all the cohorts. So when you design your survey, and that's one of the things we'll be doing for this class, you want to consider perhaps a mix of things, or if you're doing cold contacts, try those cold contacts in different parts of the campus to try to sample from different cohorts within the university. Any questions about this? Does that make sense? Yeah. All right. Now, in person is a lot more time and labor intensive. You physically have to go out and do that. It takes time. Also, it takes energy. But one of the benefits of in-person survey is that you get to capture the nonverbal things, the body language. So if somebody said, hey, tell me about your student experience, and they had a closed posture and a frowning, that's something they're not happy about. If somebody said, tell me about the academic instruction, and he or she rolling the eyes, maybe they're kind of something's going on there. If somebody kind of looks up and to the left, like they're reliving a pleasant experience, this body language is very, very important. People communicate not only through the word and through speech, they also communicate non-verbally, and you can't capture that with an online survey, but you can with in-person. Now, of course, you could have free-form essay type where you just write the responses. You could also have a tape recorder or a digital recorder of some sort. Most smartphones have them, but with a digital recording, you're going to have to transcribe it, right? So there's a little bit more work there. So there are all sorts of ways you can do this in-person survey. And this last one I had to add in many cases in industry, these are paid surveys, right? Versus we're going to do volunteer because we don't have a budget to pay people or survey. Some people have a raffle. You can write in your name to enter to win something for your participation. So there are many ways to do this. Any questions about this? No? All right. So for online, you could also have cold contact. You just email people. Well, first of all, you have to get the email list. And secondly, your hit rate on people filling out the survey is going to be low because spam is a real thing these days, right? They're less likely to answer it. If it's warm, okay, they're more likely to answer it. But if your questions contain points of a sensitive nature, they're less likely to share it with you if they're warm contact versus a cold contact. But the thing that you want to make sure is that you're guaranteeing for sensitive topics anonymity. You have to protect the identity of the people who are answering your survey. Now, of course, if the survey count, number of people filling it out, is low for a certain cohort, you exclude them because it's easy enough to identify them. Okay? All right. Any questions about this? Does that make sense? No? All right. No questions. So one of the considerations, there are many considerations to keep in mind when you're doing a survey design, is something, and this is particularly important, asymmetric power relationships. If you are a TA and one of the people who is your, what's that word? TAE? No, student? One of the people you're TAing, there's an asymmetric power relationship. It's not equal. And so someone might think, gosh, if I don't participate in this survey, they might not help me as much. If my professor gives me a survey, this might impact my grade. And so anytime you design a survey, you have to consider the power relationship between the person conducting or administering the survey and the cohort of individuals who are taking the survey or being surveyed. That's really, really important. You also want to consider if it's anonymized or if they're identifiable. Now, sometimes you want to make them identifiable because you want to sort these groups into cohort. Are you a freshman, sophomore, junior, senior? Are you a commuter or are you a residential student? Are you a first generation college student or are you not, etc. Right? So you want to also be careful that it's anonymized, but sometimes you have to reveal some data in order to produce your personas to be able to talk about your cohorts. And then this last one is particularly important, Institutional Review Board, or IRB, and I'll talk about that in the next couple slides. Now, the IRB, or Institutional Review Board, is a committee of individuals, both at the university as well as in the community, could include folks like psychologists, social workers, physicians, elected officials, and so forth. And this board is required for any institution that does research, and they review and adjudicate your research protocol. And the reason for that, and I'll talk about a little bit, is to make sure that any research that involves so-called human subjects, that includes a survey, is done ethically, and you're protecting people's welfare and their rights. And you're also adhering to federal and state laws. Okay, and so there has been a sordid history, and these are just two better known examples. There's been a sordid history in the United States of gross research misconduct. A famous one is the Tuskegee syphilis experiment, and that went on up to 1972. And they took some impoverished African-American males. Some of them were purposely infected with syphilis, and others, they were lied to, told that they were treating them for something then that was called bad blood. Now, of course, this was a community that didn't have access to a lot of education and also did not have access to much medical care. So it was really easy for those researchers working on behalf of the US government, yes, the US government, to exploit these people. The other one was the hepatitis studies at the Westbrook School for Children. Yes, for children. And so they exposed healthy children who were mentally retarded to hepatitis. And if you don't know what hepatitis is, it attacks your liver. Yes. And the parents who signed their kids up were guaranteed acceptance into this facility. So here it is, you're a parent, you have this student, this child who has special needs, and you're aching to get your child into this school that has these wonderful programs to provide for their training, their welfare, specifically tuned to them. And you can all of a sudden get admission if you participate in this study. It was exploitative, it really happened, and there are many such examples throughout history. And so there was a law put in to, or was a bill rather, put into law, the National Research Act of 1974, and it's still in play today. And it talks about principles of good ethical research conduct. And it's based on a couple points: informed consent. You have to tell people what you're doing, why they're doing it, and they can opt out with no consequence anytime they choose. You have to have respect for persons, especially if these persons have diminished autonomy. A child under the age of 18 by law cannot consent to things. So you have to have extra special protections in there to guarantee that should something go awry, A, they know exactly what you're doing, and B, they can choose to opt out if they want to at any time with no consequence. And so in that case, you can't dangle admissions into a program for children as a consequence of participation. You have to offer them that participation regardless of whether they choose to complete the experiment or drop out of the experiment. Okay. And then justice. Who's going to receive the benefit of your research? You have to treat everyone equally. You can't say this person is not allowed to participate or this cohort. When I did research on medical monitoring, we went through IRB approval. That was at my previous institution. You have to go through a lot of training. You have to take some exams and get certified. And then when you conduct the experiments, you have to follow your protocols that you've registered and have been approved by IRB. For example, if you are instrumenting someone's walking gait, a piece of wood under their shoe so that their walk is irregular, and they're walking outside for some distance, what happens if someone goes into cardiac arrest for some reason, right? You have to have emergency staged in order to address that contingency. So this IRB is quite serious. And in this class, we're going to be designing an experimental protocol, specifically our user survey for the student community at Clark, right, about student life. And so what we're going to do is have an assignment at some point soon so that we can catch the IRB cycle for the month of February. They meet once a month. So we can get that approved so that we can actually conduct the user survey in March, okay? So this is just to let you know some of the business requirements, so to speak, for doing research. And if you're doing surveys and your surveys will be published or made available publicly, this information, like on a website, you have to go through IRB approval. Any questions about this? No? Make sense? All right. And so this persona, as described in the design thinking book, is a caricature of a particular archetype, a type of user, among the cohorts that you're pitching your solution towards. And you're going to talk about what they hope to achieve, what they don't like, what they need to be done, and example ways they're going to use your system. And so this is a result of going off doing your user research. You'll cluster together people based on the results, and then you'll use those clusters to design these caricatures, or as they're called in design thinking, personas. Any questions about this? No? Make sense? Okay. And so let's pivot a little bit. We only have 10 minutes and we'll finish the balance of this on Friday if we need to. Let's talk about digital I/O. Now, when we did the bounce chaser, we used digital output. We sent voltage in the form of a logic 1 or plus 5 volts to the resistor, to the LED, and then it lighted in a prescribed pattern driven by your finite state machine. Now, we start out in our program, we had our preprocessor commands to define some useful things. You could do it for the baud rate for serial begin. You could do that for the LED pen. It just makes it more readable, your program. So then we had the bootstrapping of the serial print system. And this is so that you can use the console on your laptop to display things that you print in your program. And then you wait for the serial output system, buffering and everything to set up. And once it's done setting up, you can then complete the rest of your setup entry point for your Arduino sketch. Now, of course, this while loop is empty, and this semicolon is what's called an empty statement. You need to idle the processor doing something, and it's waiting for the serial system to come alive. Once that completes, you're now able to do serial prints. The next thing you do is you set up each of the digital pins. In this case, that particular LED pin, LED 1, which is value 12, so pin 12 on digital I/O, you're going to set it as output, all right? So then after that, the setup is called once, and then repeatedly, loop is called. You do a digital write to that pin with a logic 1, which is high. That's a constant inside of the Arduino environment. And then you delay some amount so that you can actually see the light. It's just going to idle the processor. And then you set the LED to low, setting it to 0 volts on that pin that you just set after a delay to 5 volts. Any questions about this? No? All right, so it all should be familiar at this juncture. Now, the converse is digital input, and that's what we're going to add to this AHA alarm circuit, and we'll talk about that on Friday morning in more detail, but it's very similar. Again, you have your preprocessor section of your program. In this case, we have something I'm going to call sensor, and we have the baud rate, and you'll notice I'm adding a global variable. Because it's digital input, you're going to be reading something on the digital I/O line. So if you're going to read something, you have to store it someplace, okay? So we need a data structure or a variable that's going to hold the value of what it is that we're reading in from our sensor through digital input. Now, again, in our setup entry point, we set the baud rate through serial begin because we want to print some things out to the console. We again wait for the serial port system to set up for the console. We then set our pin, and you'll notice here it says pin mode sensor, but instead of output, it says input. And so part of your setup, it's the same digital I/O line, but in this case, you're going to be reading in information. And input is a constant in the Arduino environment. So then a setup completes. It's a one-time, either when you plug it in or each time you hit the reset button on your board, it's going to run the setup. And that's where you do your initialization. So now the loop is called repeatedly, again and again and again. And we're going to do a digital read. Before, we did a digital write. Now it's a digital read. When we do the digital read, it's going to read that input digital I/O pin that you set up in the setup routine for input, and you're going to give it the pin, in this case sensor, which is pin 12, through the preprocessor, and it's going to return back a value, whatever was input into the digital I/O. Now, if you connected plus 5 volts to the digital I/O, it's going to read a logic high. If you connected ground to digital I/O, it's going to read a logic value of low, of 0. Now, it doesn't matter if there's an actual sensor there. You could be applying voltages for logic high and logic low to this digital input pin, and it'll give you the same behavior. So that's all your sensor is doing. Only your sensor is giving you this signal in the digital input pin as a result of transforming energy from the environment into an electrical signal. Any questions about this? Does that make sense? All right. So now, once we read that value, it's either high or low. If it's high, then we're going to call some routine that does something, whatever that something is. If that value is not high, we bump down to the else clause, and it's going to do something else. And so that's a basic loop of how you set up your digital I/O pin for input, and then how you read that pin and then do something as a result. Okay. Any questions? No questions? No? All right. So let's take a look at a sensor and an actuator that we're going to use on Friday for the AHA alarm. One is called a PIR motion sensor. And this PIR motion sensor has a pyroelectric sensor or crystal. And this crystal is kind of funky, right? Whenever you subject it to thermal gradients, to changing heat signatures, it polarizes. So that means the positively charged electrons and separate from the protons. And when that thing changes polarization, as you change the heat across this pyroelectric crystal, when it polarizes and unpolarizes, it's read in as a voltage. It generates signal, electrical current, as a result of heat that moves across it. And so this is tuned to body temperatures. It measures warm bodies. If you've ever walked into a room and look, the lights come on, there's a pyro sensor somewhere, this PIR motion sensor. And so we are going to use digital input with this to detect a body. And as a result of that, the action taken through the actuator is going to be to play a song. Now, the song is going to be produced using this actuator called a passive buzzer. Now, when you give it logic 1 plus 5 volts, it clicks an element through a piezoelectric crystal. This crystal is such that when you energize it with current or charge, it's going to vibrate. So you give it 5 volts, it pushes, you give it 0 volts, it comes back to rest. And when you do that, it creates a pressure wave in the air, which we perceive as sound. So if you do this at the right rate, we perceive that pressure wave at varying frequencies as different frequencies of sound. You string them together and you get music. Okay. So with this, we're going to use the analog control of voltage, but you're using it through the digital I/O pin, because we're only giving it plus 5 volts, a logic 1, or 0 volts, a logic 0. But you can tinker with how you give it plus 5 volts and 0 to give it the illusion of discrete levels of voltage. Okay. And so here we have time along the horizontal axis, and we have voltage along the vertical axis. And here we've marked 0 volts, which is a logic 0, and we've marked positive 5 volts, which is a logic 1. So going along in time, if we first give it 0 volts, and it's kind of hard to see this red line going to the right, and then some instant later, we give it 5 volts for some period of time. And then we do that again and again and again, we get what's called a square wave. Why is it called a square wave? Because it looks kind of square. Well, really it's rectangular, but you know, electrical engineers aren't always the best at physics. But that being the case, we get a square wave. And the square wave, you'll notice the amount of time, delta t, where we have 0 volts or logic 0, and the amount of time, delta t, going to the right along the horizontal axis, for which we have 5 volts, it's the same. So that means 50% of the time, it's a logic 1 or high, and the other 50% of the time, it's a logic 0. Now, this idea of the proportion of time that it's high has a name. It's called the duty cycle. And so by changing the duty cycle, you can impact the effective amount of voltage that is perceived by the component to which you're delivering the square wave. And so this is an example of a 50% duty cycle. So here's 25%, here's 25%, is 50%, right, in a square wave. This is a 75% duty cycle. You can see here, 25%, 25, 25, 25. So 75% of the time it's high. This is a 25% duty cycle. We have 25%, 25%, 25%. So 75% of the time it's low, 25% it's high. And so for some devices, like a motor, it treats this duty cycle proportionally the amount of time that it is high, it treats it as a different voltage. Now, the coils in the motor perform mathematical integration, right? And if you do integration of a constant, it's 1 over that constant, right? If you just say integral of 5 dt, it's 1 over t times that 5, right? And so what this integral behavior does, as you increase or decrease the duty cycle to the component, it acts like some fraction of 5 volts more discretely, not just this square wave. Now, this idea of varying the voltage by tinkering with the duty cycle has a name. It's called pulse width modulation. And this is a technique you can use with the speaker to control the sound that you play out of it, but it's also something you use with motors to control the amount of voltage and therefore the speed that the motor will turn. Okay, any questions about this? Okay, makes sense? So we only have 2 minutes left. Let's end there, and we'll just finish up on Friday. So please make sure you're taking a look at all the things. If you have any more questions about project number 2, I'll be on Slack until 10 p.m. That's my hard threshold this semester. We'll see what happens. But I'll see you all on Friday. We'll take a look at the AHA alarm, and on the afternoon session on Friday, we'll actually wire it up and do some experimentation. Okay. Any questions? No? All right, so with that, I'll see you all on Friday, and it is time.